Bismillahirrahmanirrahim. In today's video, we'll be solving an chapter question 12.14, and this is at the request of a student who is facing problem in getting the correct answer. So let's see. This is the question. Now, two things you have to note, which initially I did not notice, and I just went by the solution manual and tried to figure out. But let's see, if we compare with the standard circuit that we have been learning for the delta and Y connection, you can see this third arm here, in negative of all three are connected to the neutral. But here, negative of these two, but positive of this is connected to the neutral. So this is wrong. This cannot be then a balanced circuit. Number two, this point is connected with the B line, apparently looks like. But this should have been redrawn like as shown here. So these are the two mistakes. But in the solution manual, what he has done is, he has corrected this part, that is, he has connected the negative to the neutral, but 100 minus 120, he has written at 100 plus 120 just by changing the sign, which is wrong. So the solution manual solution is also wrong, but let's see what he has done. You can see the difference. Positive is connected to neutral, so this is wrong. Here he has changed it. Negative, he has connected the neutral, but this sign from minus 120, he has made it to plus 120, which cannot be done. When we change the sign, we have to either add or subtract 180 degree, not 120. Okay. Now what he has done is, he has written three equations, one for this mesh 1 and the other for mesh 2. I'll not go into the details, you can just follow it. And third for this mesh 3. And then he has found the line current, IAA. This is line current, and this line current is obviously equal to I1. So I1 and I1 he has calculated, I1 and I2 and I3. He has calculated by solving these three equations. Mesh 1, Mesh 2 and Mesh 3 equations. By solving, he has got these three currents, I1, I2 and I3. And then using this logic that IAA is I1, so he has written that I1, but IB is actually, it is going from here, B to B, that means I2 minus I1. So that is what he has written and got the answer. And the third answer he has got ICC. So this is opposite of I2. You see, I2 is coming like this, and our CC is going from here to here. So we have used minus sign. Okay. The technique is good, but this is not a balanced circuit. In the balanced circuit, all the three line currents should have same magnitude. Only the angle should differ by 120 degree. So the whole solution is wrong. Okay, now let's see. And after I checked this in third edition, then I checked it in the fourth edition, fifth edition, sixth edition, and all they have is the same mistake. I'm amazed why the author did not correct this or did not notice this. Anyway, I also had errata of the fourth edition, so I went back to the errata, and then there he has highlighted this problem. The polarity of the voltage source having a minus 120 angle, like this one, is backward in the textbook. So it is backward. That means negative should be here and positive should be here. The negative end should be connected to the negative end of the 2 voltage source. Additionally, there should be no connection between B and C. So this is assuming that there is a connection. So this is also wrong. And a corrected version of the figure is shown, which I could not open it. Okay. And then he is also saying one could solve the problem exactly as it is given, as has been done in the solution manual, and claim that there is no typographic error, but then the circuit is unbalanced. And as we have seen, that all three currents are not same. Therefore, we can say the circuit is unbalanced. But this question is given under the heading of a balanced circuit. So now let's solve the corrected version. So we have corrected this minus 120, and we have also aligned this. And then the easiest way will follow first of all. Okay, so the easiest way is that we convert the delta into y. And to convert delta into y, we just divide delta by 3. So zy will be 4 plus j4. And then we can eliminate these, the delta signs. So the circuit will look like this. And then we can connect the neutrals. So this neutral and this neutral we have connected. And we can only solve for one phase as shown here. So we can just solve for one phase. And then the other two phases will be only the phase difference. So let's see. So we have solved it here. 100 divided by these two. So the answer will be 12.8 angle minus 50.19. And then the other two, that is BB, only the magnitude will change. So 12.8, IA 12.8, with this current angle we'll add minus 120. So this will be IBB. And with the other we'll add plus 120. So this will be the angle for ICC. Now let me show you how you can do it easily with the help of a calculator. Your calculator should be in complex mode. If not, go to the mode, select 2 for complex. So we are in complex mode. And then we just need to divide this. So we'll use this sign. 100 angle 0. Don't need to write angle 0. It is 100. And then in the denominator, we can write 1 plus 2j, that was 2i, plus 4, and plus 4i. Go ahead, equal sign. Now this is in rectangular form. To go into the polar V, shift, complex, 3 for r theta, 3, equal sign, and then the answer you can say 12.8, 12.8, and angle is minus 50.19. So this is how you can directly solve using your calculator. Now this is the answer. You don't have to go further, but those who have a curious mind, or they want to follow the long method, that you can do that. We are just following the same technique that the solution manual has done. First of all, we're writing equation for mesh 1. So I'm sorry, I had just used my pen to verify, or to show you the verification. So minus 100, then 1 plus j2 I1, then 12 j12 and I1 minus I3, and then we come here 1 plus j2, and we are here I1 minus I2, and then this voltage source plus 100 and minus 120, and rearranging or solving, we get this equation in terms of I1, I2, and I3, and the constant. And similarly for mesh number 2, this is mesh number 2. You can start from here and go like this. And mesh number 3 is just around this. So these three equations, and we can summarize, these are the three equations. And you can follow any method, but I prefer to write them in matrix equation form. So these are all in matrix form. And then I have explained the technique in one of my videos that you can name these as A, B, C, D. And why we are naming them A, B, C, D? Because in our calculator, you can see these are the variables that we can assign: A, B, C, D, E, F, X, Y, and M. So 14 plus J is A. Let's see, this is also 14 plus J 16, so A. Then 1 plus J2 minus 1 plus J2 is B. This is also B. And then C, 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 C. This is D, E, and F. So we have to assign this these values first of all, and let me do that. Do you understand? Clear? We have to input the value 14 plus J16. So 14 plus 16I, and then this is store option. So shift store, and we want to store it as A. So we press this A. So A, it has been stored as A, and then B, C, and let me see. B is minus 1 plus 2I. Shift store B, and then C is minus bracket 12 plus 12I. Shift store as C stored, and then D is 36 plus 36I. Shift store as D, and E is 173, 173.2, angle 30. Shift, this is angle sign, angle 30, and shift store as E. So this is stored. And finally F is 173.2, angle shift, angle minus 90. Shift store as F. Okay, so all done. And then after that, what we have to do, we can write the delta in terms of ABC, ABC, BAC, and CCC, and we can solve, as we know how to solve the determinant. So A, and then AD minus CC, similarly minus B, and BD minus CC. So this way we have written this, and then we can solve by using the calculator, and we will get this value and we'll convert this value. So let's see, I'll just show you one. So now to enter, we have to use alpha every time. So alpha A bracket alpha A alpha D AD minus alpha C alpha C bracket close. So once we have entered all these values, like I have done it here, then we just press equal sign. So we get this answer. You can see this is in the rectangular form. And from here, we convert into polar shift complex 3 for r theta, equal sign, so 9316.84, 145. So this is the way that you can find all of these. So delta 1, delta 1, we just replace the first column with the n value EF0. So we have replaced that. For delta 2, we replace the middle column with the n value and then solve. So having solving, and we can now find I1 is delta 1 over delta. So just writing these two. This is our I1, and I2 is delta 2 over delta. So this is I2. We don't need to find I3 because this is not used in our finding of the three currents. So IA, as we have discussed, it is just I1. IAB is I2 minus I1, and IC is minus I2. So these are the three values, and it is exactly same that we calculated just by using the one phase, single phase. So it is 12.8 minus 50, 1918, this one, and then this one is 12 minus 170, 180, and this one is 12.8, 69.8108. I hope you have been able to follow this. Please let me know through your comments. Thank you.